Hey, welcome to The Art of Code. My name is Martijn, and what you see behind me here are all different versions of the same effect called the Truchet effect, which was originally invented by this guy. And it's not really that hard to make, so I thought I'd make a video about it. So if that interests you, stick around. All right, so the way this works is that we divide the screen up into a bunch of boxes. And then inside of each box, we're going to put a very simple graphic. One simple graphic you could put is just a diagonal line. That's probably the simplest that you could come up with. And then we fill all the other boxes with the exact same pattern, so that we get a bunch of diagonal lines like this. And now what we're going to do is we're going to either flip or rotate some of these tiles at random. And so when you do that, you can get a different kind of pattern here that starts looking like a maze. So that's the basic idea behind Truchet. It's very, very simple. So let's try to make it. All right, I have here a brand new ShaderToy. And the first things I'm going to do, like I usually do, is get rid of some comments. And then also I am going to make a black screen. So I'm just going to set everything to 0. And then I'm going to change my UV coordinates as well so that the origin is in the middle. So I just do times 0.5 or minus 0.5 times I resolution dot xy. And then I also want to account for the aspect ratio of the screen. So for that, I just divide by the iResolution.y. So that just gives me a black screen and a nice starting point. So we're going to divide the screen up into a grid. So for that, let's multiply our UV by some larger number so we get a bunch of repetitions. And now I'm going to make a vector 2, call it GV for grid UV, and that's going to just take the fractional component of my UV. So let's visualize that. So col.rg equals GV, and there are a bunch of boxes. Let me just zoom in a little bit as well. Okay, so the next thing is I'm going to draw the outline on these boxes. So for that, actually, right now in each box, the origin is in the lower left corner. Let's make the origin in the middle. So for that, I just subtract 0.5 from my coordinates. So now the origin is at the middle, and it goes from minus 0.5 to 0.5 in both the x and the y direction. So now I can draw an outline. I can say if my gv.x is larger than 0.48 or gv.y is larger than 0.48, then draw a nice red outline like that. So now we have a bunch of outlines, and so now I can get rid of this and we can still see what we're doing. So now let's start drawing a diagonal line into this. And for that we can use this grid UV coordinate. If I just have a quick look at, let's say, my x component, then you can see that gives me a horizontal gradient that goes from minus 0.5 to 0.5, and 0 is right in the middle. Same thing for the y component, but in a different direction. So if I add these two together, then I get a diagonal gradient, and I can use that gradient to cut a line. And so for that, I can use a Smoothstep. Actually, let me just call this mask here. So float mask equals this. And then at the end, I'm just going to add the mask so that we can see it. So that doesn't change anything. And so now I can use a Smoothstep to cut something out. And let's cut it out around 0. So let me just take two values that are really close around 0, and let's just see what this looks like. So this gives me a step around 0, but because everything in the lower left half of the box is negative, it just goes black there. We don't want that. So let me just, actually let me just go back here for 1 second so we can look at this. So what I want to do is I want to get rid of this negative. I want to fold it over into the positive. And for that I could just use an absolute. That just makes all the negative values positive. So now it goes from positive some number all the way to 0 right on the diagonal, and then back to some positive number. But now the 0 is right in the middle. So if I use this, because my smooth step is built to put an edge at 0 basically. And because 0 right now is right in the middle, I'm going to get like a really, really thin line like that. And also I want to change these values around here to get a white stripe on a black background as opposed to the other way around. But I want to give some thickness to this, and to do that I just have to sink this entire thing into the ground a little bit. So if I subtract from this, then the entire absolute, so an absolute would look like this normally, where the negative values that used to be negative are now positive, and it just gets pushed into the ground a little bit, and so that gives me some thickness here. If you want, you could put this in its own variable so that later we could change that. Equals 0.1, let's say. All right, great. So now we have all of our diagonal lines, and now we want to, at random, flip some of these lines around, right? Well, to flip the line, luckily it's not that hard, because what we can do is we can just take one of the coordinates and just multiply it by -1, and that will make all the negative values positive and all the positive values negative, so it will just flip things around like so. But we want to do that at random. And so if we want to do something at random, then the first thing that we need to think about is we need to have an identifying value for each one of these grid cells to tell them apart. And so for that, I'm going to make an ID value, which is also a vector 2, that is just going to keep track of which grid cell we're in. And for that, you can just use the floor of the UV coordinate. And let's visualize that real quick. So col.rg plus equals ID. And now you can see at 0 here, it's 0 and 0, and then it's 1 and 0, 2, 0, 3, 0. Like over here, you can't really see much, but let me just multiply it by some smaller number. And now you can see that every box here has its own color. And over here it's black, but that's just because the numbers are negative there. So now that we have that, we can use that ID value to generate a random number from that. So for that, I have to make a function that does that. So I'm gonna make a function called n21, which stands for noise21. I could have also called it hash21. Really, it is a hash. Maybe I should call it hash. So this kind of function is called a hash. And it's called 21 because it takes 2 values as an input and it returns 1 value as an output. So there's different kinds of hashes. Like one that you put 1 number in and it gives you 2 numbers out, or one that you throw 3 numbers in and gives you 2 numbers out, stuff like that. So that's what that 21 stands for. So let's just write this out real quick. P times vec2. So what I'm doing here is I am multiplying my vector 2 by some larger number, so that the vector 2 is a lot larger than it used to be, and then I take the fractional component of that, meaning like the decimal part of the result of that, so meaning that now my P has an X and a Y somewhere between 0 and 1, and then I'm going to do this little math trick here to add some randomness to this, where you can't really see anymore what you're you can't really see the pattern anymore, so it looks more random. And then return fract, and I'm going to do some more math operations just so that it looks very random, even though it isn't. So that's that. So let's have a look at that real quick. So I'm going to go over here, I'm going to go float n equals #21, and then I'm going to throw my ID value into it because I want a different random value per box. And let's just look at that real quick. So plus equals n. And so now I have a bunch of different grayscale values in each box, and that's because it's a different random number. And so now I can use that random number to start flipping those diagonal lines at random, right? So this will just return me a random number between 0 and 1. Okay, and so what I can do here is I could say, well, if that random number turns out to be smaller than 0.5, which half of the numbers are going to be smaller than 0.5, then flip it. So this will flip at random half of the tiles. And that gives me something like that. So now if we turn off the boundaries, then we get this, and let me just zoom out a little bit. And so we get this nice looking maze. UV plus equals I times, let's just make it move. So that's already pretty cool. Let me just stop it again. So there is one minor thing with this, and like if you wanted to go for some sort of retro LCD screen effect, then maybe these notches are nice, but I don't like them much, so I'll try to get rid of them. And yeah, the reason why we have these notches is because that happens on the boundaries between two cells, and so we don't want the line perhaps in the middle that goes from one corner to another corner. If we just look here real quick, so right now we have a line that goes from one corner of a box to another corner of the box. What I want is actually two lines that instead of going from the corners to the box, they go from the center of the edge to another center of the edge, or a center of the other edge. And so if we do this, then we don't have that corner issue where it makes a notch. So let's try to do that. So let me just first turn off the random flipping so that we can see a bit better what we're doing. And so let's see here, what do we have? Let me just pull this out here. So this absolute value here, and call it D for distance. And let's put that over here. So that shouldn't change anything, and it doesn't. And now the first thing to realize is that like if we want to move this line here, we can just subtract over here some number that will move the line, right? And if I subtract 0.5, then it will move it exactly to where we want it. But now we want it on both sides, so we want one line here and we want one line over here. Well, that can be achieved by just putting an absolute around this here. And now we have two lines instead of one in the middle. And now if we do this, now we have it much nicer. So let me also make the width a little bit bigger. Maybe not that big, something like that. And there we go. So that is how you would make a maze. And okay, so that is one way to do a Truchet. That's kind of like the simplest pattern that we could come up with. There's one pattern that's just a little bit more interesting, and so let's have a look at that. So instead of having two lines that go from the center of an edge to the center of another edge, let's make that two circles that basically do the same thing. So let's try to do that. Let's go back here and let me just turn my edges back on. And why did they not come back? Not entirely sure why my edges didn't come back. Let's turn that back off and let's make this a bit smaller. Where did my edges go? Okay, like it's because it's too small, you can't see them, so okay, they're back. All right, so this is straight lines, so let's do the same thing with circles. So for a circle, this D value would be a little bit different. If you remember from other videos, the way you can draw a circle, let's say if we're looking at this box over here, the way you can draw a circle is by asking the question, okay, how far is my pixel, the current pixel that we're at, how far is it from the center of the circle that we're trying to draw? And the center of the circle would be in the top right and in the bottom left. So let's look at the top right first. So the way we would do get that distance is, well, that's GV, which is the current pixel location, minus where we want the circle to be centered, which is at 0.5, 0.5. So that's that, and let's see what that does. Okay, so that gives me a circle that is at the top right corner, but it's too small. Why is it too small? Because, let me see here. Yeah, because my radius, the radius of the circle was 0. So I want the radius of the circle to be 0.5 so that it goes exactly to the middle of the edge. And then, let me just get rid of this here for a second. Okay, so this goes exactly to the middle of the edge. And then we have to like make that into an outline as opposed to a filled circle. So how do I do that? Let's see here. Let's take the absolute of this minus the width. Okay, there we go. All right, so that is one circle done. Now we can make another circle by just copying this. We could copy this over here and do the same, like add to it with the same kind of smooth step, so something like that, and then put the other circle at minus 0.5, and that would give us both circles. But the only thing that's really changed here is this minus, so let's see if we can't make something better for that. So let me just cut that out, and actually we can probably get rid of this as well. Yeah, this is the same thing, because if this is a vector 2 and you subtract the float from it, then it treats it as a vector 2 as well. So we can be a bit shorter. And so the only thing that we want to change here is it's either minus or it's plus, right? So how can we do that? Well, we could multiply this 0.5 by a number that is -1 for every pixel in the lower left half of the cell, and it is +1 for every pixel in the top right half of the cell. So let's try to do that. We can use this for that. So if we just have a look at this again, and that was just our diagonal gradient, which is negative in the lower left half of the cell and positive in the top right half of the cell. Well, we can turn that into -1 and +1 by just using the GLSL sine function, which will return -1 for any negative number and +1 for every positive number. So we could use that. So let's multiply this 0.5 here by this sine function. And let's see what that does. And now you can see we get the second circle practically for free, which is great. There's just one minor issue with this. We see like some white pixels over here, and that is because this sine function can also return 0. Like if in the case that gv.x is exactly the negative version of gv.y, then this will be 0, and therefore the sine will return 0. And we don't want that, so I found a quick fix for that. It's not the nicest fix, but if you have anything better, leave it in a comment below. But other than that, this works just as well. Just adding a very small number just to shift it away from 0. Okay, so now we have this, and let's have a look what that looks like. So there we have a beautiful Truchet looking effect. How cool is that? Let's have a look at that. Awesome. All right, so next, let's try to make this look a little bit more interesting. So let me just stop this. And let's try to put some sort of texture on this. And for that, I'm going to use the angle that the pixel, if you would draw a line from the pixel to the center, the angle that that line makes with the line that goes straight up. And for that, I can use an atan function. If I go over here, atan, so the atan will measure an angle. So I can call float angle equals atan something. And what the atan needs as an input is my coordinates in terms of the center of the circle that I'm trying to get the angle of. And I have that coordinate, and that coordinate is this entire thing inside of the length over here. And so let's take this out and call it circle UV, CUV, back to CUV equals this. And so let me just test that real quick to make sure I didn't. Okay, so that works. And now we can just use CUV.x and CUV.y. And that will give me an angle between minus pi and pi, or pi minus pi to pi. And because pi is a trigonometric number, right? It works well with sine and cosine and whatnot. Let's just stick this into a sine wave and see what happens. And now we can see we have some nice gradients on our arcs. And if I multiply this by some larger number, then it's more clear what it does. Now let's try to animate this. So for that, I can just shift the phase of the sine. So for that, I could just add I time to this entire thing. And now you could see that everything is moving. And that's already pretty cool, but it would be nicer if we had consistent motion across tile boundaries. Because right now, at every tile boundary, we can see that either it's converging or it's diverging, right? Luckily, it's doing that at every single tile boundary. So that tells me that, you know, that there's probably something we can do about this to fix this. And what we could do is we could shift the direction of the movement of every other tile. And so let's try to do that. And yeah, how do you change the direction of the movement? Well, you just change the sign of this angle over here. So if I make that minus, then it goes the other way. But it shouldn't go the other way for all of them, because then we just have the same issue. So we need something that does it for every other tile. And let me drink something. Okay, so for that we need a variable that I will call checker that will be on, off, on, off, on, off. And to do that, we can use a modulo and throw our ID into it. And let's just look at the X component first. We take the modulo 2 of the ID, and let's look at that. Call plus equals checker. And so that gives me black, white, black, white, black, white. And why does it do that? Well, my ID value, let's say it's 0, then I'm going to do 0 divided by 2, and then the remainder, which is 0, therefore it's black. And for the second row, it's going to be my ID.x is going to be 1. And so you're going to have 1 divided by 2. What is the remainder? Well, it's 1. And for the third one, it's my ID.x is going to be 2. So I'm going to have 2 divided by 2. What's the remainder? It's 0. And so this will go from 0, 1, 0, 1, 0, 1 all the time. And obviously that same thing for the y. And if I add these two together, plus ID.y, then I get this nice checkerboard pattern, which is pretty cool in its own right. You can use that for many different cool things. All right, great. So now, now my checker goes from 0 to 1. I don't want that. I want it to go from -1 to 1. So for that, I will multiply by 2. So now it goes from 0 to 2. And now I will subtract 1. So now it goes from -1 to 1. And now, if I, well, also let me get rid of this here. like so. Now we have it like that, but if we multiply this angle by the checker value, then all of a sudden everything starts moving in a consistent direction. So that's pretty cool. Okay, so let me just clean this up a little bit. Let me call this flow. So flow or a consistent flow for a Truchet effect, it works for some Truchet tilings, but not for all of them. This simple quad Truchet it will work with. But yeah, for more complicated ones, often you can't find consistent flow. So let me go over here, call that flow. All right, but what I'm actually more interested in is to make a usable UV coordinate onto the Truchet squiggles, so that we can put any kind of effect. We can bend any kind of effect into the shape of the Truchet vines, which is much more powerful. So let's try to do that. And so for that, I'm going to make an X and a Y. And let's look at the X first. So the X of our UV coordinate would be, well, pretty much the same as the angle. It's just that the angle goes from -pi to pi, and I don't really want that. And so what we can do is divide it by, well, actually no, let's just have a look at this first. Okay, so this one goes from 0 over here to, well, a whole revolution would be 2 pi, so it goes from 0 to 1/2 pi over here, meaning that it goes from 0 to 1. 1 is like somewhere over here. I want to stretch that out so it goes one quarter revolution before it does that. So for that, I'm just going to divide it by 1/4 pi, which I believe is something about that. So now it goes from 0 to 1 over here. And there's ones that we can't see because they're negative. If you want to be able to see those, you could just put a fract around this to bring everything in the 0, 1 range. And that's our X coordinate. So now let's have a look at our Y coordinate. So for the Y coordinate, I would want to, well, let me also make this a little bit bigger so we can see it a bit better. For the Y coordinate, so the X coordinate goes along the squiggle, and the Y coordinate would be perpendicular to it. And so for the Y, we want to, let's say the Y would be 0 on one side of the squiggle and 1 on the other side of the squiggle. And so for that, we have to use the distance that we calculated before. And let me see here. Where is this distance? Okay, so I have this D value over here. Yeah. Let's just move this -0.5 because I want just the length itself. So let's move that from here to over here. That shouldn't change anything, I hope. So no, that doesn't change anything. And so now we have this D value that is the distance from the closest circle. And okay, so let's look at that. So float Y and Y over there. And let's just look at the D and see what it looks like. Okay, so this already works. It's just that it's not normalized to the actual vine itself. And so let's try to do that. So we want it to be black on one side and white on the other side. Or in other words, 0 on one side and 1 on the other side. And so let's first look at the 0. So for the 0, I would just have to subtract, because right now it starts counting from all the way from the corner. So I would just have to subtract 0.5, which is the radius of the circle, and then minus the width. And the width, I'd call it width here, but it's really half of the width. So that would bring the 0 point all the way to the inside of the circle. So let's have a look. And now you can see that the inside of the circle is black because it's at 0. And so now we have to make it that the other side is at 1. And to do that, I'm going to take this entire thing here and we're just going to divide by the width of the squiggle. And the width, I just said that this is actually only half of the width, so I would have to do divided by the whole width, which would be that. And so now I have it black on the one side and white on the other side. And so that could be our y coordinate. Now you could see one very obvious issue with this, which is that depending on which way the squiggle in the next tile is oriented, you might get a discontinuity where all of a sudden your texture flips or your texture coordinates flip. And unfortunately, there's no easy way to remedy that and to make it completely uniform, because you would have to know, one tile would have to know how all the other tiles are oriented in order to know which way to flip. And so that's not feasible. So we have to do something else, and the next best thing that we can come up with, or that I could come up with, is to just mirror our UV coordinates so that it's symmetrical along the center line. And so for that, so right now the UV goes from 0 to 1. So if I subtract 0.5 from that, then it would go from minus 0.5 to 0.5. And if I take the absolute value of that, then it goes from 0.5 to 0 back to 0.5. So that's what that looks like. And then we could just normalize that by multiplying by 2, so it goes right back to 1. And so that is our y coordinate. So let me make it a bit bigger. And that kind of looks already pretty cool. So let me just make our full UV coordinate. So TUV for Truchet UV, and it has an X and a Y. And let's look at both of them at the same time. So RG and then TUV. All right, so now we have some candy color looking, cool looking thing, which is pretty neat. Yeah, actually on its own, that's pretty neat looking. But the whole exercise was about generating UV coordinates so that we could map something else onto it. So now you have the power to put anything onto this. So you could take somebody else's shader, put it in a different on a different tab here, and you could render that shader bent inside of your Truchet effect if you wanted to. Or you could have a hierarchical Truchet where you take a Truchet pattern and you bend it inside of another Truchet pattern. Or you could just take a texture. So let's take a texture and see what that looks like. So I'm going to go over here, and let's take the Nyan cat because it kind of lends itself well to this. And now over here, let's slap that sucker on there. So I channel 0, and then with our UV, and that doesn't work because it returns an alpha channel as well. So we have to just do .rgb. And there we have a bunch of Nyan cats. So let's animate that. So inside of here, I could just add I time to this, times some smaller number so it doesn't go super fast. And yeah, obviously for the angle, we have to do that same checker trick to get a uniform movement. And there's one thing here, which is that you see some edges. And that has something to do with MIP mapping. The way to get rid of that is, if you just use this to look up from a texture, then you don't need to fract. And actually it's better because it will get rid of some of the seams that you would otherwise get. Also, the Nyan cats are going in the wrong direction, so let's just do that. All right, so that's that. And what else? Yeah, so that UV coordinate, you can use that, right? You can use it not just to look up a texture, but also for shading, for instance. So I could multiply by t.uv.y to get some shading onto this. And maybe not like this, maybe we want it the opposite way. And yeah, so to get some more 3D looking thing. And what else can we do? We could change the width of this based on some location on the screen. So for that, let me just go over here and say vac2 equals, so let me just get the original UV coordinate without any transformations on it. So UV coord.xy divided by I resolution.xy. So that just gives me a standard UV coordinate from 0, 0 to 1, 1 over there. And then we could use that, for instance, to change the thickness of the vines. So let's say at the top of the screen, they're a certain thickness, and at the bottom of the screen, they go completely to 0. And let's move this here. All right. All right, there we go. So that is the Truchet effect. That is the simplest version of the Truchet effect. You can so this is called a quad Truchet because the tiling that we're using is just a standard quad tiling. But you can tile the plane in a gazillion different ways. So there's the regular tilings, the quad tiling, and the triangular tiling, and the hexagonal tiling. But if you check out Wikipedia, there's like literally 117 ways to tile a plane, and so you can come up with a Truchet effect for any one of them, and they will all look different. So this is a lot of fun to play with, and yeah, I hope you liked it. If you made it this far, my apologies for not making a video earlier. It's been summer, I've been busy. I've worked on another project that you can check out over here if you want to see the bottom half of me, for instance, and you want to see something completely different, then check that out. I even managed to get a Truchet effect in there to make it nicer. So yeah, that's it. I hope you like it, and I hope to see you next time. Don't pull. It's so hot here. That's so cool. So this, I guess, is what happens after